Before we run our Terraform setup, one last thing we need to check is to make sure our setup is correctly done. Some of the points that you need to check closely is the locals.tf, where we transform our variables, and also the data.tf. We'll just start with the locals.tf. When we come at the top here for the tags, make sure it's a valid Terraform map. Then we have a shared ingress rule. This should be actually shared egress rule. Then make sure you copy this, go to main.tf, and then under Fargate security group, you need to use egress, not ingress. Next, downwards, make sure you check these rules. This rule has to use self as true. This one should be null so that it will take the default. When you scroll downwards under profiles, make sure the names are spelled correctly. So we need to make sure we have a kube system profile. So make sure you use the correct spelling for the key and also for the name, because this name will be used to create the profile, and if the name doesn't exist, then the key will be used to create the profile as the name. The namespace, make sure it's also spelled correctly, cube system. Then another key profile that we need is the one for CodeDNS. This is where the CodeDNS pods will be run. So make sure you also create the correct key. The key can be in lowercase, but the name has to be case sensitive, the way I wrote it here. And then it has to be created with the cube namespace and also this label so that it can match the CodeDNS pods. Lastly, when you're adding your own profiles, make sure you use a unique name and also check the spelling correctly, because this name will affect how you deploy apps on your cluster, unless you are willing to add new profiles to fit the new naming convention that you'll be using. For this case, you're only adding this once, and then now we run a test. But also you're not limited to having only these profiles. You can dynamically add as many profiles as you want, and you can also get rid of older profiles once you move your applications to the new profile. For this Fargate profile, the name is apps. Then we had a multitude of selectors here. We are starting with a default namespace. The first label doesn't use a regex or a regular expression, just uses a full name for the label, and also it uses the default namespace. The second one uses the default namespace, and then it uses a prefix with a wildcard regular expression here to match all namespaces that will be using this as their prefix. Then you also have a second one for apps namespace. The first two are for the default, the second two are for apps namespace. The last namespace uses a wildcard matching technique that will match all namespaces that will begin with apps hyphen, and the profile the same. So this is the label you'll just be using. You can use any label you want. For this case, I'm using profile, and I'll show you where this comes in when you are running the sample applications. Another key thing to check is to make sure that the subnet IDs passed to the Fargate profiles must be private subnets. You cannot use public subnets for the Fargate profiles. Another critical point is to make sure these plugins are spelled correctly. This is not an underscore, so it's not an underscore like this. It's a hyphen for the VPC CNI, also for the pod identity agent if you need it. And then for CodeDNS, this is very critical. Make sure this is spelled correctly, because this is what is read inside our cluster. So let me just show you inside our cluster module, main.tf. When you come to where we are creating the cluster add-ons, right here, you can see what is being read for the configuration value is the key configuration. Now this configuration object, the compute type has to be camel case like this, and it has to be of the type Fargate. Lastly, this is just the function or the steps to obtain the plain or IDC ID from our cluster. We'll review the variables.tf. From the top here, we have the region, and then we have the project name. Make sure none of these variables is empty. Then for the VPC, we have the CIDR. Make sure these are valid CIDR. Then we have the private subnets, the public subnets. We also have the private subnet tags and also the public subnet tags. Then for the EKS variables, make sure nothing is also empty. For this tutorial, I'm filling up all the defaults. Here we have EKS unique ID. For this case, I'm using Fargate. Initially, I had used cluster, but I just noticed within the cluster module itself under locals, we are already appending cluster. So I changed this in the main variables.tf file Fargate so that it makes more sense. Then the IAM default path can be /. You can use any name you want here. You can use something like dev, staging, or pilot. Then here we are using the IAM role path. This is the default role path, by the way. But if you have a specific requirement in your organization, you can set it here. Just make sure all these other variables are supplied. There is nothing we are passing in without a default value. Once you've confirmed every variable has been set, let's move on to the data.tf. Make sure you have these three in place: the partition, caller identity, and session context. Make sure you have the availability zones. The IAM policy documents also should be here for the load balancer trust policy. For these ones, I'll share them, and actually to make things easy, I'll just share the entire repository with you so that you can reference everything after you set up from the video. For this other policy, it's too long. Just make sure you copy it from a repository and then you add it to yours while setting this up. The other file we can review is the versions. Make sure you're using the correct versions, and also you've set up the correct providers down here. For the outputs, make sure you output everything you need. This is what we'll need for setting up our application. If you need any additional details, you can pass them in here. And for the main.tf, make sure you have the following. You have the VPC module initialized. The key points for the VPC module is to enable DNS support, enable hostnames, enable NAT gateway to allow internet access. And then for this case, we are not doing a production deployment. We'll only have one NAT gateway for the two availability zones. But if you are doing a production scale deployment, you need to disable single NAT gateway so that you have multiple NAT gateways for redundancy. In case one availability zone goes down, your VPC will still be reachable through the other zone and your resources won't be blocked from the internet. Then for the public subnets and the public tags, we reviewed that in the variables. Also for the private subnets and the private subnet tags, we reviewed that. You can get creative here by adding the other variables. So here we have our tags in the local.tags because this is the main module and we are just merging it with this. Then the second module should be the cluster itself. So make sure you have the variables set up correctly and also the dependencies. For the cluster itself, it has to come after the security group. So make sure the dependency is correct and also you've supplied every value correctly. For the VPC at the top here, initially I had put here 2, but you're supposed to use 1 because you only have 2 subnets, as you can tell from the variables.tf. So we'll only have 2 public subnets here and 2 private subnets. So we cannot select 2 here because we only have 0 and 1 from the set of zone names that will be returned. We have this local exec command that is put under the Terraform data resource. This one will just be running the EKS update kubeconfig command using the AWS CLI. This is why you needed to install the AWS CLI. So this one will depend on the cluster module. It will only be run after the cluster has been created and also everything that the cluster relies on has been created. Lastly, we'll need to create the load balancer controller policy. We'll not be installing the controller within Terraform. We'll be installing it using Helm on our local, and that's why we needed to configure the access to the cluster here. So the policy will be read from this data resource that we just reviewed, and then the role trust policy will also be read from this data resource. They are next to each other in the data.tf file right here. Lastly, we need to attach the policy to the role. That's why we have the role policy attachment. We need also to review our modules quickly. Under the security group, we have the main resource that takes in dynamic values to allow you to pass in multiple sets of ingress roles and also egress roles. For this module, we only need the project name that is passed in as name, and the rest of this. Make sure each variable uses the correct type. If it's a single string, make sure it's a string. If it's a list of a custom object, make sure it's also defined correctly, like this one. For the Fargate profile, just review the outputs. If you need any, add them here. The variables, make sure they're matching the correct type and also they have the right description. For the cluster, the same thing, just reference everything from the KMS key variables and also the resource, the IAM roles and policies, the cluster itself, and then the log group. Make sure you take note of this module also. The add-ons, just check to make sure everything is passed in as expected. And then we finish with the profiles, which are coming from a sibling module that is just outside the cluster module in the modules folder. When you get this repository, you'll get the load balancer controller values.yaml for the Helm command here. And then you'll also find the IAM policy for the user that you need to create to run this Terraform setup here. This is the one that has been optimized for readability so that it will be easier for you to just group everything together or to review and compare with your own settings. And then you'll find the example subfolder also with the 3 example apps. The good thing is that these apps are all hosted on remote repository, either public ECR or public Docker registry, so you can use them across or substitute these images with your own images. That marks the end of our review. We're now ready to execute our code and see how it goes.